Good morning, good afternoon, or good evening. This is Mr. P. Wonderful to have you all back. Today we're going to be doing guided notes for section 10.5, angle relationships in circles. So, a circumscribed angle is an angle whose sides are tangent to a circle. That is, notice that angle B, its rays are tangent to the circle, and so we call that a circumscribed angle. Intersecting lines in circles. If two non-parallel lines intersect a circle, there are three places where they can intersect. Perhaps they intersect on a circle, in the circle, or outside the circle. Not really any other options. Theorems. Tangent and intersected chord theorem. That is, if a tangent and a chord intersect at a point in the circle, then the measure of each angle formed is 1/2 the measure of its intercepted arc. That makes sense. That's always the case when it comes to inscribed angles. So that means that arc AB is twice the measure of angle 1, or the measure of angle 1 is half of AB, and measure of angle 2 is half of BCA. Angles inside the circle theorem. If two chords intersect inside the circle, then the measure of each angle is 1/2 the sum of the measures of the arcs intercepted by the angles and its vertical angle. That is, this angle and this angle, which by the way are congruent because they're vertical angles, are equal to half of the sum of BC and AD, and these two angles are equal to half of the sum of those two together. That is the average of them, because they have to be the same measure anyway. Angles outside the circle theorem. If a tangent and a secant, two tangents or two secants intersect outside of a circle, then the measure of the angle formed is 1/2 the difference of the measures of the intercepted arcs. That is, angle 1 is half of BC minus AC. In this measure of angle 2 is half of the difference between PQR minus MPR, or a measure of PR, excuse me. And angle 3 is half of XY subtract WZ. Half of the difference between those. Circumscribed angle theorem. The measure of a circumscribed angle is equal to 180 degrees minus the measure of the central angle that intercepts the same arc. That is, ADB, this, is equal to ACB, this. Take that away from 180 degrees. That is, these two angles, angle D that we made, and then the central angle, are supplementary. Tangent and intersected chord theorems. Find the indicated measure, arc AB. Well, since the inscribed angle here is 101 degrees, AB is twice that. So the measure of arc AB is equal to twice that of the measure of angle angle A here. I really need it. BAD, twice the measure of angle BAD. But since we know that's 101 degrees, 2 times 101 is 202. So the measure of arc AB is equal to 202 degrees. Okay? Now, the measure of angle 1 here, we don't know it, but we need it to, it's half of that arc, but we don't know that arc. But we kind of do, because its arc complement, we'll learn that later, is 248 degrees. So if we do 360 minus 248, because 360 is the whole circle, so the rest of it, 360 minus 248 is equal to 112 degrees. So the measure of that arc is 112 degrees, and the measure of the angle is going to be half that, which 112 divided by 2 is 56 degrees. So the measure of angle 1 is 56 degrees. Now I need the measure of arc FH. Same problem here, except here's the thing, is that I don't know what HGF is, but I know what angle HF, I don't know, Q, why not? I know what the measure of that angle is, and it's 129 degrees. which means arc HGF is thus twice that. 129 times 2 is 258 degrees. That's this arc here. And since the circle is 360, I have to do 360 take away 258. And that will give me the measure of arc FH. It's 102 degrees. So the measure of arc FH is 102 degrees. Angle inside the circle theorem. So remember, the measure of these two angles are the same because they are vertical, but they are the average of the two arcs they cut out. That's how I want you to think of it. So that means that x equals the average of 92 and 50. That's 92 plus 50 divided by, not 20. 92 plus 50 is 142. And 142 divided by 2 is 71. So x equals 71. As for here, well, okay, that's fine. Let's find the measure of that angle first, because then we can find the measure of these angles, because they are supplements to those. So if these two angles here that I'm not asked about are the average of 41 and 53, 41 plus 53 is 94, and 94 divided by 2 is 47. That means that that's 47 degrees, and so is that. But since these are supplements, I should be able to take 180 degrees minus 47 degrees and get x. So 180 minus 47 is 133 degrees. So x equals 133. Now these ones aren't like the average. This is the one where it's the sum of the differences. So notice these are tangent, so that's 138 degrees. A whole circle is 360, so that's the rest of it. So that's 360 minus 138. 360 minus 138 is 222 degrees. And this angle x is think of it as, it's almost like finding the averages, except you're subtracting them. So x equals the bigger angle, 222, minus the smaller angle, 138, divided by 2. Now 222 minus 138 is 84, and 84 divided by 2 is 42. So x equals 42. The same story comes over here. It's not a different thing. Except now we know what that's 24 degrees. I don't know what that arc x is, and I know that's 118. But what I do know is that this angle, 24, is equal to half the difference of the bigger arc minus the smaller arc. Multiply both sides by 2. And that's 48 equals 118 minus x. And I'm doing that really because that's what would have happened over here. Take away 118 from both sides. 48 minus 118 is negative 70. So negative 70 equals negative x, which means that x equals 70. Cool. Yuck, but we can do this. That means that 39 is equal to the difference of these two, that is the big arc, 17x plus 6, take away the small arc, 7x minus 2, divided by 2. Distribute that minus sign. 39 equals 17x plus 6 minus 7x plus 2 over 2. 17x minus 7x is 10x, so 39 equals 10x plus 6 plus 2 is plus 8 over 2. Multiply both sides by 2. 78. I'm sensing a theme here. 78 is equal to then 10x plus 8. Solve it the normal way. Take away 8 from both sides, leaving me with 70 equals 10x. Oh yeah, divide both sides by 10. And hey presto, you get x equals 7. And it all comes from there. That is, these angles are half the arc length because of what we talked about last section. These angles are the average of the two arc lengths that they cut out. And these two act like the average of the arc lengths, except you subtract instead of add. Finally, circumscribed angle theorem. Find the value of x. So let's make sure we look at that theorem really quick. We don't forget it. A measure of a circumscribed angle is equal to 180 minus the measure of the central angle that intercepts the same arc. So that is to say, these two angles, 130 degrees and x degrees, are supplementary. That is, x is equal to 360. Oops. X is equal to 180 minus 130, which is 50. So x equals 50 because those guys are supplementary. That's something that we were told up there. And there you have it, folks. Angle relationships in circles. I hope that made sense to you. If you have any questions, make sure you send a message to your instructor. This is Mr. P signing off, and I hope you have an excellent rest of your day.